Hi students, welcome to this video. In this video, we are going to discuss the experiment number 8 of the operating system lab, which is page replacement algorithms. Okay, so to introduce to you, let us see what paging concept is. Okay, then we'll learn what is page replacement. Why do you require page replacement algorithms and the various types of page replacement algorithms? So in this video, we'll be learning about all these basics and learning about the 3 types of page replacement algorithms. Okay, so to begin with, what is paging? For example, OS divides your virtual memory as well as your main memory into units called as pages. Okay, so and each page or each use page can be in the secondary memory or a page frame in the page frame in the main memory. Okay, so what basically happens in paging is when a CPU wants to execute a particular page, okay, what does the CPU do? The CPU will search for this particular page in the main memory. Okay, now if the page is not found in the main memory, then it will check. Then that case is actually called as page fault. Okay, if for example, if CPU wants to execute a page and that particular page is not available in the main memory, so that scenario is called as a page fault. Okay, now what does the CPU do is CPU will load that particular page from the secondary memory to the main memory. So if a same case, if a CPU wants to execute a page and the page is present in the main memory, that is called as a page hit. Okay, and if it is not present, then we call it as a page fault. Okay, so when memory located in the secondary memory is needed, it can be retrieved back into the main memory. So the process of storing data from main memory to secondary memory, that process is called as swapping out, and retrieving your data back to the main memory, we call it as swapping in. Okay, so you have understood what a page is, what a page fault, what a hit is, and what is the process of swapping out and swapping in is. Okay. Now, in an operating system that uses paging for memory management, page replacement algorithm is needed. Okay. So as I said previously, as I said, when a CPU wants to execute a particular page, it will check whether that particular page is present in the main memory. If it is not present, then we say it is a page fault. Okay. And then it tries to load that page from the secondary memory to the main memory. In case if the main memory is completely full, okay, there is no space to accommodate the required one, what happens? You want to replace a page in the main memory, okay, and that decision is based on the page replacement algorithm. So based on the various page replacement algorithm, we see how a page is replaced from the main memory in case if your main memory is full. Okay, so here in the slide, I'm just explaining again what a page fault and page hit is. So page fault is nothing but when a running program accesses a memory page, okay, that is mapped into the virtual address space but not loaded into the physical memory. Simply, page fault is nothing but if a CPU want to execute a page and it is not found in the main memory, we call it as a page fault. Page hit means if you find the required page in the main memory, when the CPU wants to access that page, then it is called as a page hit. Okay. Now, see, for all the page replacement algorithms, there's a basic algorithm, there's a basic structure of algorithm that is followed. Okay. So to explain that algorithm, this particular diagram is best suited. So what happens? This is actually a physical memory. Okay. Now, the CPU checks for a particular page in this memory. Okay, and that particular that particular page is not available in the memory. So what happens? It has to now take that particular page from the secondary memory and then store it in the main memory. In case if your main memory is full, you need to now take one page out of this main memory. Okay. So how do you take is based on some page replacement algorithm. Okay. You have to take that and then take the page from the secondary memory and load it into the main memory. Okay, so this is what happens, as I said. So here in this diagram, you can see this is your physical memory. So there was no space to actually put. So first what you have to do is take a page from the, you have to free a particular page, or you have to free a particular space in the memory to fetch into the to fetch a new page into this. Okay, so this is actually we are planning of taking this particular page out of the physical memory in order to accommodate the page that is required by the CPU to access. Okay, which is not available in the main memory. So in order that what you're doing, you're taking a page which we call it as a victim. Okay, first thing that you have to do is you have to swap this victim page, okay, into the secondary memory. Okay, once we do that, what happens, the main memory is now, the main memory is, this part is actually empty, which means that there is no more page in this particular place. Okay, so that updation has to be made in the page table. Okay, what, so you have to change to invalid. You have to change, this is actually the frame and this is to write whether this particular bit is to depict whether it is having a valid or an invalid bit. So since because we have removed this page, we have to update in the page table stating it is a invalid. Now after that, what you have to do, you have to swap the desired page inside the physical memory. See, this case happens only when CPU access a page and that particular page is not available. Okay, that is the time when page fault occurs. So what happens, you have to take the page from the you can CPU loads a page from the secondary memory to the main memory. In case if the main memory is full, that is where we are doing all these things. Okay, so we select a victim page, you will swap into the secondary memory, then you make that changes in the page table, then you will be swapping the desired page, the requested page by the CPU. It will be loaded from the secondary memory to the main memory. Now, this particular page, this particular page from the secondary memory has been swapped here. Okay, so that again, that particular change has to be referenced in the page table. So you have to change it. You have to reset the page table for the new page. Now you have inserted a new page inside the main memory, right? So that change also has to be reflected or updated in the page table. So you have given V, which means it's a valid bit, and you have specified the frame. Okay, which means that a new page has been come into the main memory. Okay, so this is a basic diagram that will explain you the flow of algorithm that is being carried out by various algorithms. This is the general principle that happens with all the page replacement algorithms. Okay, so say first thing, find the location of the desired page on the disk. Then you have to find a frame. If there's a free frame, then you can use. Okay, if there is no free frame, okay, in this case we didn't have a free frame, that is why we made the swap in and the swap out. Okay, so if there's a free frame, then you can use it. If there is no free frame, you have to use a page replacement algorithm to select a victim frame. As we said in the diagram, we said that we are selecting a particular victim page in the main memory. This selection is based on some page replacement algorithm. Okay, after that, what you do is you have to write the victim frame to the disk, change the page and the frame tables accordingly. You have to change the page tables accordingly. After which, the third step that you do is you have to read the desired page into the newly freed frame. Okay, freed frame. So here we have freed the frame. So you're now swapping the desired page into the free frame. Okay, after which, okay, again you have to change or give the updates in the page table. Okay, and then continue the user process from where the page fault has occurred. So this is the basic steps that will be followed in this case. So this diagram is typically explaining you about how a page replacement is being carried out. Okay. Now, what are page replacement algorithms? Okay. So page replacement algorithms, they deal with pages that need to be swapped out and which are the ones that to be swapped in. So it's nothing but, as the name says, it is replacement of your pages. Okay. So that is nothing but swapping in and swapping out of your pages. Okay. So if a question is to where the efficiency of this page replacement algorithm is, the efficiency is based on the least time that is wasted for a page to be paged in. Okay. So the least time that is wasted for a page to come inside is the efficiency of that particular algorithm. Okay. There are two types of replacement strategies, the local page and the global page replacement strategy. And why do we require page replacement algorithm is to provide low page fault rate. Okay. In order to provide the lowest page fault rate, that is why we go for various page replacement algorithms. We'll be looking into three basic algorithms. First one is FIFO, then the optimal and the LRU. So all these algorithms work in different ways. Okay. The main idea or the main requirement of going for a page replacement algorithm is to minimize or to have the lowest page fault rate. Okay. So if you start, you send a page request. Okay. So if a page is found, then you say it is a hit. If the page is not found, we call it as a fault. Then what you have to do, you have to fetch the page. Fetch the page in the sense you have to load the page from the secondary memory to the main memory based on some algorithms. Okay. If the main memory is full, you have to free a particular frame, which is called as a victim frame. Then you need to allocate, do the necessary updations in the page fault. So this is actually the flow of the algorithm. Okay. So, sorry, flow of the page replacement that is happening. Okay. Now, this is just a graph to show the number of page fault versus the number of page frames. Okay. Now, the first type or the first algorithm that we are going to discuss is first in, first out page replacement algorithm. Okay. So as its name says, the replacement algorithm is based on a first in, first out, which means the page which came first will be going out first or which will be replaced first. Okay. The page which has come in first will go out or which will be replaced first out. Okay. First in, first out, nothing but FIFO. We call it as FIFO. So in the pages in the memory is actually kept as a list. Okay. And the newest page is the head, and the oldest one will be in the tail. Okay. First in, first out. So new pages will be kept on will be inserted onto the head, and the oldest one will be lying on the tail as it is shown in this particular figure. Now, this FIFO algorithm is considered to be one of the simplest page replacement algorithm. So in this algorithm, what does the operating system do is it will keep track of all the pages in the memory in a queue, and the oldest page is in the front of the queue. Okay. So when a page is supposed to be replaced, the page in the front of the queue is selected for the removal. In short, it is nothing but the oldest page will be chosen for your replacement. Okay, let us see to an example so that you will understand more. So this is just to show a FIFO example. This is a reference string 7012030. This is actually the reference string that we see. Okay, now we'll see how many. So the size of the main memory we are giving at page, the frame size or page size is 3. Okay, so that is why we gave it as 3. Now we are going to try with these reference string how many page fault would occur based on the FIFO concept or FIFO replacement algorithm. Okay, so here in the FIFO example, the reference string, as I said, is the reference string that you see in the screen now. Okay, so first is first you're going to check whether 7 is present in the main memory. So initially main memory is empty. So 7 page is not there. So we insert it in the main memory. So this is actually a page fault. This is not a hit because 7 was not there in the main memory. So we loaded it into the main memory. Next reference one is 0. 0 we check in the main memory. 0 is not there. So we loaded 0 into the main memory. So now this is also a fault, page fault. Now coming to 1 is also not there in the memory. We are loading it into the frame. Okay, this is the one which we are, this is the newest one that has come now. Okay, now next one is 2. So 2 has the next in the reference string, the next page is 2. So what you have to do is now already when the reference string has come to these 3, already the memory is full. Now, when I'm taking 2, we need to choose which frame to change, which has to be changed, which page has to be changed. According to FIFO, what does FIFO say? It is first in, first out. So the first page that came inside the main memory was 7. Okay. So according to FIFO, the 7 will be replaced by 2. Okay. So it becomes 2, 0, 1. This is also a page fault. Now, next is 0. Okay, in the reference string, it is 0. We are checking whether 0 is present in the main memory. Yes, it is present. So it is not a page fault. It is a hit. Okay, so when CPU is trying to execute a page called 0, it's already there in the main memory. So it need not have to take it or load it from the secondary, or you need not have to load it into the memory since because it is already present there. So then it is a hit. It is no more a fault. Now the next one is 3. Okay. Now 3, in this case, in the main memory, 3 is not present. So what you have to do, you have to replace with the page in the main memory and you have to load 3. So which is the first among these, which was the first one, then you have to replace, that is 0. So 3 came in, then 1. Next is 0. Okay, 0 is no more there. So you are going to replace 1, which is a, as far as the first in, first out concept is concerned, which is the first one that came inside has to be replaced. Okay, so 1 will be replaced with 0. Now next 4 is not there. So here in the previous case, according to this, 2 is the one. So 2 will be going out, 4 will be coming. 4, 3, 0. Next again 2 was not there. So again 3 will be removed and 2 will be replaced. This is all based on the FIFO concept. First in will be replaced. Okay. Now after that again it is 3. So it was not there. 0 is removed and 3 is brought in. Next it is again checking for this thing. So finally see here when it comes to 3 is already there. So this is not a page fault. It is a hit. Now again the reference string, it is 2. The 2 page is already there. So it is no more a page fault. It can execute by taking it from the main memory itself. You do not have to exchange or replace anything. Okay. So again that is a hit. Now coming to 1 is not there. So then 2 is replaced by 1. So this is, so likewise, it will, the entire reference string will be looked to find how many page fault occurs. So totally, how many, in this particular example of the reference string given, there are actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. 15 page fault occurs. Okay. 15 page faults and how many hits? 4 to 5 hits. Okay. So FIFO is considered to be one of the simplest example for that matter, where for 3 frames, the size of the main memory was taken as 3 frames, okay, or the size is 3, main memory size. Based on the number of frames which is assigned as 3, the number of fault that occurs is 15. Okay. So another one thing that happens with FIFO is, if, for example, if you increase the size of the frame, for example, here this frame size is 1, 2, 3, right? We have given only 3 frames. For example, if I give 4 as a frame size, okay, there can be a possibility that you can reduce the number of page fault, okay. At the same time, it is not, we cannot assure that if you increase the frame size, the page fault may decrease. Okay. So there are two possibilities. If you increase the frame size, for certain cases, it might decrease the page fault, but certain cases, it will increase the page fault. Okay. For example, if another string is given, okay, if the frame size is 3, for example, the page fault is 10, suppose. Okay. In another case, if your page frame is 4, and then you've given a string, the page fault becomes much more reduced. Okay. There are different cases such likewise. Okay. So what happens is, if you increase the frame size and still it is the page fault is increasing, then that scenario is called as Belady's anomaly. Okay. In order to overcome that particular Belady's anomaly, that is why we go for the optimal page replacement algorithm. Okay. So in optimal page replacement algorithm, what happens is, okay, it will replace a page that will be used for the longest period of time. Okay. When the memory is full, in case the main memory is full, then the page that will be unreferenced for the longest period of time will be replaced. Okay. So when you take all these basic examples of various algorithms, optimal page replacement algorithm is one algorithm that will provide you with the lowest page fault rate of all the algorithms. Okay. And it is very firm that this particular algorithm will not suffer from Belady's anomaly or anomaly. Okay. So this is a major advantage of going for optimal page replacement. But at the same time, see, with only 9 faults, optimal replacement is here in this example. We see take care of optimal page replacement algorithm. So this is the reference string that is being given. Okay, see, first the main memory is empty. So first 7, so page fault, it is loaded into this memory. Next 0, again 0 is not there in the memory, so it is again loaded. It is a page fault. Again 1 is also not there. Okay, so again it is loaded into the memory. Then it is going for checking 2. 2 is present or not? Yes. 2 is not there. Okay, so what you have to do? The one which optimal is what? That replaces a page that will not be used for the longest period of time. So this was not, this 7 is the one which is now not used for a longer period of time. So 7 is replaced by 2. Now coming to the next string, that is 0. 0 is already there. So it is no more a page fault. So it is a hit. Next is 3. So when it comes to 3, which is the longest one, which is a page that is not being used for the longest period of time here now, it is 1. Okay. So what happens? 1 will be replaced by 3. Okay. So this is how our optimal example works. Optimal pagement replacement works. The longest period of time, which is the unreferenced page, that will be replaced. Okay. So in this particular example, with this particular reference string, there is basically 9 page faults. Okay. There is only 9 page faults that is occurring. If you count 1, 2, 3, 4, 5, 6, 8, 9 page faults are only occurring. Okay. So with only 9 page faults, optimal replacement is much better than a FIFO algorithm, which results in 15 faults, right? So in this examples, we say that with the same 3 frames, we had only 9 faults, whereas in the FIFO, with the same 3 frames with the string, we had 15 faults. So which is considered to be more efficient? The optimal page replacement algorithm is considered to be more efficient. Okay. So if we first ignore the first 3, see, this is the first 3. Okay. This is likely to be common for all the algorithms, because once the memory is empty, you will have to load it. Okay. So considering in all these examples with 3 frames, considering these 3 exceptions, okay, if you ignore the first 3 cases, which all algorithms will have to suffer, The optimal algorithm is twice as good as the FIFO replacement algorithm. Okay. And moreover, as we said that no replacement algorithms work as best as optimal replacement algorithm. Okay. And optimal page replacement is one of the algorithm which has the lowest page fault rate. Okay. So this is how a optimal page fault algorithm works. Now, the main disadvantage of going with optimal page replacement is that it is difficult to implement, okay, because it requires the future knowledge of the reference string. You need to know the reference string in advance, okay. So you need to know the future of it, without which implementation is going to be a little difficult. And that is why we basically use this page replacement algorithm for comparison studies. Okay, implementation level we don't go high, but then for comparison studies it's giving a better result. Okay, the last algorithm that you're going to see here is the least recently used. Okay, so the basic distinction between the FIFO and optimal algorithm, optimal page replacement is otherwise called as OPT or MIN algorithm, opt or min algorithm. Okay, so FIFO or FIFO will use the time when a page is brought to the memory, whereas opt uses the time when a page is to be used. Okay, so this is a basic difference between FIFO and optimal. FIFO will be taking the time when the page has come to the memory, whereas optimal will be using the time when the page is to be used. Okay. Now, when it comes to least recently used or LRU, it will be swapping the pages that have been used the least period over a time. Okay. And this is also free from the Belady's anomaly. So here, this is the LRU example that you're seeing. Okay. So this is a reference string. So first three cases is almost the same like everything. Okay. Now coming to the 2, it will be recently referenced. 2 will be 7 will be replaced by 2. Then coming to 0, 0 is already there, so it is a hit, which is recently. So now 0 is being recently referenced. You cannot change that for that matter. Okay, you cannot remove. This is recently referenced. Okay, now coming to 3. So you will replace 1 with 3. So the least recently used pages will be swapped in the case of LRU. This is how the least recently used works. Okay, so for your exercise, you will have to you have to get the input where you have to get the number of frames. Okay, you have to give a reference string, and you have to get the output of how many hits and how many misses, how many faults. Okay, are there, how many hits and how many faults would be there. Okay, this is how you have to find. So the basic concept, you have to implement these three algorithms for the exercise, that is first in first out page replacement, optimal page replacement, and finally the least recently used algorithm. Okay, so you have understood how the concept is. So the basic input for all these algorithms is, first you have to get the number of frames and you have to give a reference string. Based on that, your output should be the number of misses and number of hits. Okay, so hope you've understood the concept. You have to implement the program based on this.